Assalamu alaikum wa rahmatullahi wa barakatuhu. Today we will start our new subject electric machines EEE 371, and the book we are going to follow is Electric Machinery Fundamentals by Stephen J. Chapman. I am Dr. Ch.Arshad Mahmood from Department of Electrical and Computer Engineering, ComSearch University Islamabad, Aptabad campus. So before going to the details of the subject, let's look at the prerequisites that I hope you have studied and you have basic knowledge of these subjects. So these are electric circuit 2, electromagnetic theory. So the basics will be required from you people that you have the understanding of these subjects. So there is no core requisites, means you don't have to study another subject along with this subject to understand this subject. So this is the course catalog description. This you can find it in your course catalog that you got while you took the admission. The book we are going to follow for this subject is Electric Machinery Fundamentals by Stephen J. Chapman, 5th edition, and we will select some of the topics from this Electric Machines by Charles I. Hubert, 2nd edition. So I will let you know when you have to follow this book. Otherwise, most of the content of this subject will be from this Electric Machinery Fundamentals by Stephen J. Chapman. So before going to further, we know that we are in the OBE mode. So for that purpose, we have defined these course learning outcomes. So for every student, they have to pass all these CLOs to pass these PLOs, which are the program level objectives, and CLOs are the course learning outcomes. So these are the cognitive levels C2, C3 and C4. So the whole course is divided into the 3 CLOs. The basic one is the describe the basic concepts of magnetic fields to analyze magnetic circuits and principles of operation of transformer, AC machine and DC machines. The next CLO is illustrate the construction and parameter identification of transformer, AC and DC machines. The third one is the equivalent circuits of transformer, AC and DC machines and their analysis. So these CLOs are defined such that our difficulty level of the course will be increasing with the CLOs. So this is chapter 1, Introduction to Machinery Principles. The learning objectives of this chapter are to learn the basics of rotational mechanics, which includes angular velocity, angular acceleration, angular displacement, so torque and Newton's law of rotation. Learn how to produce a magnetic field, understand magnetic circuits, understand the behavior of ferromagnetic materials, understand hysteresis in ferromagnetic materials, understand the Faraday's law, understand how to produce an induced force on a wire, understand how to produce an induced voltage across a wire, be able to work with real, reactive and apparent powers. So because this is the introductory chapter, and I hope that most of the things you already have learned in your basic courses, but we will go through them one by one. So first of all, we define what is electric machine. So electric machine is a device that can convert either mechanical energy to electrical energy, which we call it as the generator, or electrical energy to mechanical energy, to whom we call the motor. So almost all practical motors and generators convert energy from one form to another through the action of magnetic field. Now, why we are putting the transformer in these electric machines? The transformer is the basic principle of the transformer is same as any other electric machine. So, but the only difference is the transformer have no rotating parts. So that's why we usually put the transformer with other electric machines or other rotating electric machines. So the transformer is an electric device that is closely related to electrical machine that converts an AC electrical energy at one voltage level to AC electrical energy at another voltage level, normally at the same frequency level. Transformers operate on the same principles as generators and motors, so that's why we have placed them here. So why are electric motors and generators so common? So electric power obviously is a clean and efficient energy source that is easy to transmit over long distances and easy to control. That's what we have seen in different countries, that electrical transmission is made through wires and it's very easy, and there is no pollution in while we transmit the electricity. So electric motor obviously does not require constant ventilation and the fuel the way that the internal combustion engines does. Just like the uh, vehicles that we have that use the internal combustion engines, which uses the either gasoline to work. Obviously they produce some gases like carbon monoxide and other gases, which are obviously, if we just use those engines inside a closed room, so that will reduce the oxygen level, and that will be very difficult to breathe in that room. So obviously we put those generators normally which use these fuels in an open area. However, the motor is very simple, suited for use in environments where the pollutants associated with combustion are not desirable. So instead, heat or mechanical energy can be converted to electrical form at a distant location. So obviously, we have seen that our mostly these power generation plants are at a very distant location, just like Tharbela Dam, Mangla Dam, and all those, they have the electrical production unit, means they have the generators installed. So the energy can be transmitted over long distances to the place where it is to be used, and it can be used cleanly in any home, office or factory. So make sure that this cleanliness means that there is no pollutants that are produced. So transformers are the devices or the machines that aid this process by reducing the energy loss between the point of electric power generation and the point of its use. So we see a lot of transformers sometimes just beside our house. We can see a transformer that is used to uh, transform the high voltage to the low voltage. So they are normally called the step down transformers. Now, almost all electric machines rotate about an axis called the shaft of the machine. So remember, almost simply means that transformer, they do not rotate. So relative to a given end of the machine's shaft, the direction of rotation can be described as either clockwise or counterclockwise. So this is just the relative motion that we just say that whether machine is rotating clockwise or they are counterclockwise. So in this course of study, the counterclockwise angle of rotation is assumed to be positive and clockwise one is assumed to be negative, because we know that rotation is not a negative, cannot be negative. So this is just a relative motion that will show us that if we get the negative sign somewhere, so it means that our motor is rotating in the clockwise direction. So the angular position, the angle at which it is oriented, measured from some arbitrary reference point. So it simply means that if we are measuring some angle, so if we take this as the reference, so if we measure this angle, so that will be theta, and if this is rotating, and this is the rotating part, so obviously at any instant we can find its position. So sometimes in different applications where we want to control the motors, and we normally need the angular position because we are not using it as a continuous rotational machine. So angular position is usually measured in radians or degrees, it corresponds to the linear concept of distance along a line. So this is the same as we say that displacement, if we take these 2 points and this is the, we say that this is the displacement on a linear uh, concepts. So this will be the same as the, but theta obviously is in the rotation because it this any object or vector is rotating in this motion. So it is continuously rotating. So at any point we can get the position and we name it as the, so as a theta. Similarly, angular velocity, so the rate of change in angular position with respect to time. So obviously with the time, if our angular position is varying, so we call it as the velocity. So we know that it's assumed to be the positive rotation is if it is in a counterclockwise direction. So we use the omega to represent, we use omega to represent this angular velocity, which is equal to d theta by dt. So this gives me the rate of change in position. Obviously its units should be theta because theta is in radians, so and time, so it is in seconds, so it is radians per second. So angular velocity is the rotational along the concept of velocity on a line. So similarly that we have seen earlier in our basic physics courses. So omega m, here we have defined it as the angular velocity expressed in radians per second. We can define the frequency angular velocity expressed in revolutions per second, and m is the angular velocity expressed in revolutions per minute. So we have some means there we can use these different notations and their multiples to find out where, just like this, nm is equal to 60 times fm, and fm is equal to omega m by 2 pi, or as we know that omega m is equal to 2 pi f, because it's in the revolutions rounds per seconds or revolutions per second, and omega m is in the radians per second. So we can transform this, and even we can find out the frequency if we want to find the mechanical frequency of some rotational shaft. So we can use this omega m over 2 pi. Similarly, if you want to convert in revolutions per minute, so obviously because this fm is in seconds, so we have to multiply it with 60 to get this in revolutions per minute. Now angular acceleration, as we know that the acceleration is the quantity that comes until when we have the rate of change in velocity. So if there is no rate of change of velocity, obviously we will not get any acceleration. This is just like simply if the car is moving at a constant speed of 60 km per hour and it's not changing at all for over a period of time, so at that period of time we can say that their acceleration is 0. But that's the general thing about this. Now angular acceleration, because we are talking about the motors, so the rate of change in angular velocity with respect to time, it is assumed positive if angular velocity is increasing in an algebraic sense. Angular acceleration is the rotational analogous to of the concept of acceleration that I told you. So this is defined here in this book as alpha, and this is the d omega by dt, so which is obviously d square theta by dt square. So that's what we have seen earlier. The angular acceleration is measured in radians per second square. Obviously, because they are squared, so their units will be radians square by second square. Now there is another important quantity which we call it as the torque. So torque is obviously has an important quantity in the rotational machines. So the direction of the torque is clockwise if it would tend to cause a clockwise rotation. Again, this is our just assumption that we are assuming that they are positive if they are clockwise torque, and it's counterclockwise if it would tend to cause a counterclockwise rotation, and we call it as the clockwise rotation or the counterclockwise rotation. The units of the torque are Newton meters in SI units and pound feet in the English system. Now, if we look at this figure, so we can see that if we apply this is say a shaft. So if we apply the force onto on the shaft such that the angle of the force is passing through its center, so obviously this object will not move at all, and the torque produced by this rotating object will be zero, or the torque produced by this force on this object will be zero, so it will not move at all. So in order to rotate this shaft, we have to apply the force such that it's certainly at some angle, at some point away from this center of axis. Now if we push it here, and if this center point is fixed, so it will rotating in the counterclockwise direction. So we will say that the torque is counterclockwise. So obviously this is very difficult, means if we if we want to rotate it by putting a force just along the axis of rotation. So we know that the twisting force on an object is the torque. So when an object is rotating, its angular velocity is constant unless a torque is present on it. If we remove the torque, or the torque is constant, so means there will be no angular velocity. So it will be a constant angular velocity. The greater the torque on the object, the more rapidly the angular velocity of the object changes. Means at that certain point, that object is accelerating. The torque on the object is defined as the product of the force applied to the object and the smallest distance between the line of action of the force and the object's axis of rotation. So if we say that if r is the vector pointing from the axis of rotation to the point of application of the force, and if F is the applied force, then torque is force applied into perpendicular distance. So perpendicular distance obviously will be r sine theta, and this is equal to rf sine theta, where theta is the angle between the vector r and the vector f. So this would be the situation. Let me choose the pen here. So this will be the situation. Now, so if we extend it here, so this will be our theta, and this will be 180 degree minus theta, and this will be call it as the r sine of 180 degree minus theta, which is obviously equal to r sine theta. So this is just a basic trigonometric identity that you must know. So that will be the shortest distance that we have said, that will be perpendicular distance, that will be the effective part of the force that we have applied here. So this is the relation r sine theta that we have seen, and this is the force that we have applied. Now Newton's law of rotation, what it says that the Newton's law of rotation describes the relationship between the torque applied to an object and its resulting angular acceleration, and is given by the equation which we already know, F is equal to ma. Now here it is because it's the rotational object, so we have the torque is equal to J alpha, where tau is the net applied torque in Newton meters or pound feet. Alpha is the resulting angular acceleration in radians per second squared. The term J is called the moment of inertia of the object and is measured in kilogram meters squared or slug feet squared. So obviously we know that inertia is the property of the rotating object, or inertia basically is the property of the any object. So but moment of inertia is the property of rotating object. So there is another small term which we call it as the work, denoted by the capital W. For rotational motion, work is application of a torque through an angle. Here the equation for work is W is equal to integral of torque d theta, and if the torque is constant, obviously then it will be tau theta. So the units of the work are joules in SI and foot pounds in the English system. Then comes the power. So power is the rate of doing work or the increase in work per unit time. The equation of power is P is equal to dW by dt, measured in joules per second, foot pounds per second, or horsepower. So if we assume constant torque, power in rotational motion is given by d omega dW by dt, which is the rate of change of work done. And if we know that W is equal to tau theta, and tau is obviously, if torque is the constant, so that would be d theta by dt, and d theta by dt is the omega, which is the angular velocity. So if we want to measure power is made in watts, torque in Newton meters, and speed in radians per second. So power in watts is tau, which is foot pound, n is the number RPMs, rotational speed divided by 7.05. These are just the formulas. We don't have to derive them. So if you want to find the horsepower directly from this torque and n, so we just have to divide this product by the 5252. Now here comes the another basic concepts which are the very basic principles of this transform motors, electric machines, and I hope if you understand these things, so the basic concepts of your machines will be clear on this slide. So the magnetic fields, as we know, that are the fundamental mechanism by which energy is converted from one form to another in motors, generators, and transformers. So these are the four basic principles that describes how magnetic fields are used in these devices. Now the very basic one is that here one, it says that if a current carrying wire produces a magnetic field in the area around it, means if we have this wire and current is flowing in it, so it will produce magnetic field in the area around it. So this is a very basic principle that we know from our physics and the basic principles of the electric circuits and magnetic circuits and all those subjects, the same basic phenomena that we are going to use here. Now here comes the next part that's obviously is derived, you can say, from this basic principle, but it has some catch in it, and that catch is the time changing magnetic field induces a voltage in a coil of wire if it passes through that coil. So once again, if we have the time changing magnetic field means that if we have some source or the current which is time changing, so obviously the magnetic field that is produced around that wire or a coil or whatever it is, that would be a time changing according to the just like the current that we have passing through that coil. So if it is a time changing magnetic field that induces a voltage in a coil of wire, so obviously it means that if we have the time changing magnetic field by some means, and if we put another coil with it, so if it passes through that coil and if this second coil is close to that time changing magnetic field, then we will have the induction, and that will be, it passes through that coil, so the magnetic field will be induces a voltage in the second coil. I think so you got it. So I will try to repeat it in Urdu. जब भी हमारे पास एक टाइम चेंजिंग मैग्नेटिक फील्ड है और उसके करीब हम एक और कॉइल लेकर आते हैं या वायर लेकर आते हैं, तो उसके अंदर वोल्टेज इंड्यूस हो जाएगी. ये हमारे पास है बेसिस ऑफ ट्रांसफार्मर एक्शन. क्लियर होगी बात आई कि हमारे पास जब भी टाइम चेंजिंग मैग्नेटिक फील्ड होगी से, और उस टाइम चेंजिंग मैग्नेटिक फील्ड की मीन्स अगर ये हमारे पास टाइम चेंजिंग मैग्नेटिक फील्ड है और इसकी विसिनिटी में हम एक और वायर ले आए, तो उस वायर में या हम कॉयल एक रखते हैं इसके अंदर, अगर हम इसके अंदर साथ एक कॉयल रखते हैं तो इसके अंदर वोल्टेज इंड्यूस हो जाएगी। सो दिस इज अ ये हमारे पास क्या है, ट्रांसफार्मर एक्शन. So this is a transformer action. So if we have the time changing magnetic field and if we bring another coil of wire into that magnetic field, so the voltage will be induced in that coil. This is called the transformer action. Now a current carrying, say third one, a current carrying wire in the presence of a magnetic field has a force induced on it. Now catch in here is that we don't need here the time changing magnetic field, we don't need the time changing magnetic field, but what we want is that our one of the wire or coil which is fixed, and if we let other wire to move, so that will be, there will be a force on that, the field has a force induced on it, so that will produce a force on the other coil or a wire, so that will try to move it away or toward itself. So this is called the motor action. So I will try to again repeat it in Urdu. अगर हमारे पास एक करंट कैरिंग वायर है, ठीक है, और एक और हमारे पास मैग्नेटिक फील्ड पहले से मौजूद है, मीन्स हम ऑब्वियसली दूसरी हमारे पास जो वायर है, जो फिक्स हम कह लें, तो हम जो जो वायर हम जो करंट कैरिंग वायर है उसको हम जिस वक्त करीब लेकर आएंगे उस फील्ड में, उस मैग्नेटिक फील्ड में, तो उसके ऊपर फोर्स अप्लाई होगी. I will again repeat it. A current carrying wire, if we have the current carrying wire just like this, and there is another field which is already produced by, again obviously we know that that is produced by some electromagnet or some permanent magnet. So if we bring that this current carrying wire in the presence of that magnetic field, then the force will be induced on that current carrying wire. Okay, obviously we have to fix this magnetic field source so that it will not move. So this is the basis of the motor action. So the last one is a moving wire in the presence of a magnetic field has a voltage induced in it. So if we have the moving wire and if we have this magnetic field which is uniform magnetic field, which is not time varying, which is not time changing, so if we bring another coil or wire and we move it like this in the vicinity of this magnetic field, so it will what it will be, the voltage will be induced in it. So there is a slight difference between the second and the fourth one is, in the second we are not moving these two coils, but we are moving the magnetic field, we have the time changing magnetic field. But in the last one, which is the generator action, because we know that in generator we rotate the one portion, rotor of the generator in the presence of the magnetic field by some means, which we call it as the prime mover. So here we have the same concept. If we have this another wire and if we move it in this, so we are cutting these magnetic lines. So when we will cut these magnetic lines, the voltage will be induced in this second wire. I hope you have understood all these basic concepts. So for today, it's I will stop here. And if you have any questions, feel free to ask. Assalamu alaikum wa rahmatullahi wa barakatuhu.